Us now look at question 5. It says a ray of light is incident on one side of a rectangular block. So it's talking about this part. If the angle of refraction is 26, which is this part that has bent, complete the ray. Keyword is to complete the ray until it emerges from the block. Okay, there's some important information given that critical angle of glass is 42. So this angle C, and this is angle R, which is indicated here. So the question is, what will happen on this portion of the glass block, which is what we want to find out. So this is my question mark. So there are two possibilities. One possibility is that because this is traveling from glass to air, so this is glass and the surrounding is air. So glass is actually denser, considered as a denser medium than air. So if we recall our concept of how light travels from different mediums, we notice that when it travels from denser to less dense media, it will tend to bend away from the normal. Okay, in this case, we notice that there's another possibility, which is the light might be also there'll be a total internal refraction. So how do we decide what happens over here? So it's important for us to add on a normal to the surface, because the normal will help us to decide what will happen. So we draw a normal. We can now redraw this portion. Okay, we can focus on this portion, and we notice that this is actually a right angle triangle. So we draw this part here. Okay, so this is actually 90 degrees. So this will be 90 degrees. This is 26 degrees. So this will be equivalent to 90 minus 26. So this is right angle triangle. My answer is 68 degrees. So I can actually calculate that this angle to the normal, in this case is at this surface, is actually known as my angle of incidence. So this angle of incidence at this portion is actually 68 degrees. So we notice the critical angle is actually 42. So we notice that my angle of incidence in this case is actually greater than my critical angle. So what will happen is that it fulfills the criteria of total internal refraction. So what happens is, instead of bending away from the normal, it will now bend into the glass block. So it will bend. But how do we decide how much it bends? So actually, total internal refraction has told us that the angle of incidence will be equal to my angle of refraction. So in this case, I will draw the ray such that this portion to the normal will be exactly 26 degrees, because angle of incidence no, it's supposed to be 68, sorry, not 26, 68. So this part will be 68. Well, it corresponds to this part of the angle. Okay, which is this part is also 68 degrees. Okay, so we have completed this part of the graph. So we notice that it must emerge from the glass block. So at this point of time, it has not emerged. So we have to continue to draw a normal here. So this is a normal to the surface. Okay, so what will happen over here? So you notice that just now we have calculated 68 here. So there's another right angle triangle here. Can we draw the right angle triangle? Okay, on the left hand side. So this is my right angle. So this is my right angle, and this is my 68 degrees, which is over here, and this is actually my 26 degree. So you notice this is my new 26 degree, which is the angle incidence to the surrounding. So when light travels from denser to less dense medium, it will tend to bend away, or total internal refraction over here. So how do we decide whether it goes here or it goes back into the glass pot? So you notice that this is now my new angle incidence, 26. So this new angle incidence is actually less than my critical angle, because my critical angle is actually 42 degrees. So in this case, it's actually less. So total internal refraction cannot occur. I repeat, total internal refraction cannot occur because 26 degrees is less than 42 degrees at this point. So what happens is, it won't bend in, it will bend from denser to less dense, it will bend away from the normal. So you look on the other side of the glass pot, it should show a reflection. So in this case, it should bend somewhere here away from the normal. So please complete your diagram by adding all the arrows. So this will complete question 5.